In this video, we're going to solve some radical equations, and we're going to try 4 different levels here. We have easy, medium, hard, and then what I'm going to call expert, just another hard one. But if you have a problem that you're trying to solve that looks like one of these, go to that part of the video and watch that and see if this helps. All right, let's try the first one. All right, first up, we have our easy problem. And with all of these, we need to kind of follow a certain set of steps. And the first step is that we need to isolate our radical, or isolate the square root part, or really any root, whether it's a third root, a fifth root, whatever kind of root you have. I'm going to be working with a lot of square roots today. So we need to isolate that, meaning that it's the only thing on that side of the equal sign. So right now I'm seeing that there's also this -9 over here. I need to add to the other side. That's going to be how I isolate this radical. Okay, those 9s are going to cancel, leave me with the isolated radical of 5x plus 11. And then on the other side, of course, it's just going to equal 1. Now, one thing you need to know about radicals, especially with square roots or any even radical. So what I mean when I say that is there's also like third roots, there's fourth roots, and so on, fifth roots, right? And anything underneath that. If there's nothing there, that's just a square root. So it's kind of an implied 2. And any even one that you have, it needs to equal a positive number. All right, the odd ones can be negative, that's okay. But for all of our even ones, it has to be positive. If it doesn't, if I get this isolated and it equals a negative, you can stop right there in your problem. It's just going to be no solution. All right, so since ours is positive, it's a positive 1, we can continue this. And so let's do that. Our next step is we need to eliminate our radical. And to eliminate a radical, we need to square it. Or we would take it raised to the 3rd power, the 4th power, the 5th power, depending on what type of radical you have. Ours are all square roots, so we're going to square them. That's how you undo those. Okay, left over, we have 5x plus 11 on the inside, and on the other side, 1 squared is just 1. Now this turns into an Algebra 1 problem, which you've hopefully know how to solve, and we're going to solve this subtracting 11 on both sides, getting 5x equals -10, dividing by 5, and of course we get x equals -2. All right, now one other step with these radicals, these radical equations, is you have to check for what's called an extraneous solution. Extraneous solutions are solutions that look like they're going to work, but when you plug them back in, they don't, okay? So let's try that here. And in this one, I'm going to plug it back into my original green function, and I'm going to do it for every time that I see an x. So I'm going to rewrite this, and every time I see an x, I'm going to leave a space, and in that space, we're going to put our answer. If we get this side of the equal sign to equal the other side, then the answer works. And if we don't, then it's called extraneous. So for example, this one here, let me get a different color. We're going to plug in -2 because that's what we got. And if I do that here, that's going to be -10. -10 plus 11 is 1. So the square root of 1 minus 9. And does that equal -8? Well, square root of 1 is 1. 1 minus 9 is -8. So yes, that is true. And I like to show this by just putting a little check mark to show that it checks out. All right, let's try our medium level. All right, our medium level here, it's going to have 2 square roots on either side of our equal sign. And so remember our steps from earlier? Well, the first step was that we needed to isolate our radical, but here with 2, are they both isolated on their respective sides of the equal sign? Yes, they are. All right, so I can go ahead and eliminate steps 2 of this and eliminate this radical and eliminate this radical, and those are going to, the square root and the square will cancel on both, and we can actually just write what's underneath of them, okay? And so this is going to give me -5x minus 7 equals -x minus 35. And in some senses, this is actually easier than our first one, because this is just a multi-step equation, and we should know how to solve those by now. However, we have to do that last step at the end to check if there's extraneous solutions. So I'm going to solve this, and let's see if we can get an answer, and then we got to plug it back in when we're done. I like to move my smaller x. In this case, it's 5x. 5x is more negative than just -x, or -5x, as I should say, giving us -7 equals, oops, should add that there, equals 4x minus 35. Okay, I'm going to add the 35 over, plus 35, and I get 28. Positive 28 equals 4x. If I divide by 4, 7 is what I get for x. But remember, I can't just move to the next question. I have to test to see if this is extraneous or not. So I'm going to rewrite this top part and leave it spaces every time that I see an x. And in those spaces, we're going to put 7. So what I mean by that, draw a line over here. We have the square root of -5, leave a space, minus 7 equals the square root of negative space minus 35. And in that space, we're going to put 7. All right, so let's go 7 here and 7 there. All right, what is -5 times 7? That's -35 minus 7. And on the other side, -7 minus 35. So you might say this one's just -35 minus 7. That was -7 minus 35. In both cases, you're going to get -42. And you're correct. You get the square root of -42 equals square root of -42. So it looks like this is going to check out because it works. But can you take the square root of a negative? Try it right now on your calculator. No, you can't. It gives you an error. If I were to take the square root of something negative, it is not going to work. So even though it looks like 7 should be an answer, this is called extraneous. And therefore, because there's no answer that works, we're going to have no solution. No solution. This is an extraneous solution because it looks like it's going to work, but it doesn't. All right, let's try our hard problem now. All right, I got our hard problem here in red for us, and this one says the square root of 8x plus 17 equals x plus 3. Now, right away, you might be able to see why this is kind of hard, because this is already isolated, and I need to eliminate it by squaring both sides. And when I square this over here, that's going to be a binomial squared, which means you're going to have to FOIL and maybe even eventually factor. So let's try it here. Let's square both sides to eliminate our radical. If I do it to one side, I got to do it to both. That's going to cancel my square root. So underneath, I have 8x plus 17. And on the other side, when something is squared, it's tempting to do this wrong. If I were to do it wrong, I would just say this is x squared plus 9, and that is not right. Remember, when something is squared, like if x is squared, that equals x times itself. So here, if I have x plus 3 squared, it's going to be it times itself. All right, and of course I have to FOIL that. So this would be x squared plus 3x plus 3x plus 9. And then my two middles can combine to give me x squared plus 6x plus 9. Some of you should be able to jump to that right in your head. If you can't yet, you'll probably get there eventually. All right. My other side is going to stay the same over the next couple steps, so it's still 8x plus 17. Now, what I like to do, whenever I see that I have both x's and x squareds in my problem, I like to get those all on the same side and see if this is going to factor, meaning that I need to get this side equal to 0. So I'm going to subtract 8x and subtract 17. Do that to their respective terms over here. The x's have to go together. Minus 8x minus 17. On this side, those will both cancel, give me 0, which is good. That's what I want. On the other side, excuse me, this is going to be x squared minus 2x minus 8. Okay? And because, again, I have an x squared, an x, and then a constant term, or just a number, this is probably going to factor. Now, you've probably been taught to factor differently than how I do it. Every teacher seems to teach it just slightly differently. I like to make a graphic organizer to help me out. Two numbers that multiply to be my a times my c term. 1 times -8 is -8. I need two numbers that multiply to be that, and also that add to be the b term, -2. And in this case, I think it's going to be a -4 and a +2. So I'm going to use those two and pop those in right here into my factors and say x minus 4 and x plus 2. Those are the two numbers I found. If you don't know how to factor, I do have more videos on that. But anyway, this is going to equal 0. I'm going to switch my 0 to the other side since it's an equal sign. And if I set both those equal to 0 and solve, because this could be 0 or that could be 0, I'm going to get x equals 4 and x equals -2. All right, now I'm not done. I have to check those for extraneous solutions. So I got to put those back in to my problem and see if they work or not. Now, you might be able to do this in your head, so that's what I'm going to do here. And in fact, I'm going to try this 4. 4 times 8 is 32. Let's make a little mark here, 32 plus 17. Now, one little tip is normally when you put those numbers back in, underneath the square root, it will be a perfect square. All right, almost always. So here, if I do that, this is going to be 49. I can take the square root of 49 to get 7. So this side's going to be 7. And I need to decide, does 7 equal x or 4 plus 3 since my x is 4. And yes, 7 equals 7. So I can put a check mark as that one works. All right, let's try -2, see if it also works. It is possible to have more than one solution that works. They don't always have to be one that works and one extraneous. This one might work as well. Let's try it. This is going to be 8 times -2, which is -16. And -16 plus 17 is a +1. And the square root of 1, does that equal -2 plus 3? And yes, it does. Square root of 1 is 1, and that equals 1. So in this case, they both work. Both 4 and -2 are solutions to our hard problem. Let's try our expert level. All right, last problem we're going to do is what I'm going to call our expert level here. And that is because it kind of looks similar to our medium level in that I have square roots on both sides. However, I cannot isolate both like I was able to in the medium section. In this case, what you want to do is you want to isolate the most complicated square root first and get that isolated so you don't have to worry about what's underneath it that's made more complicated. So if I were to look at this, I have an x and I have an x plus 7. Which one's more complicated? The x plus 7 is, all right? So I'm going to isolate that, which it already is. It's on the only thing on that side of the equal sign. We're going to square both sides. Now, this is going to turn out to be a little bit gross over here, but we're going to have to deal with that because that's all I have in this problem. This side, though, it is going to cancel, leaving you with just what's underneath, x plus 7. Now, the other side here, I have to write this out as a binomial squared. These two terms squared, so it times itself. I'm going to do the square root of x plus 1 times the square root of x plus 1. That's what it means to square. And if I FOIL this, we have the square root of x times the square root of x. Well, that's just x, all right? That's just x, which is good. Square root of x times 1 is just 1 square roots of x. I'm going to put the 1 out here. You don't have to, but I'll show you why here in a second. All right, then I'm going to run the 1 through. That's hard to say. Run the 1 through. And you get 1 square root of x again. And then 1 times 1 lastly is 1. This side is still x plus 7. Okay, why did I put those 1s in front? Because they can combine to give me 2 square roots of x. And I'm going to have x plus 2 square roots of x plus 1 equals x plus 7. So we can probably combine a few things here. Let's try that. I'm seeing that I have an x and a 1. Over here I have an x and a 7. So maybe we can move those to the other side. I'm going to subtract x, subtract 1, subtract x, subtract 1. And in fact, that's a really nice, this one's actually not too bad. I thought it was going to be expert level, but maybe not. The x's here can cancel, which means I only have one other x left. I'm going to have 2 square roots of x equals 7 minus 1 is 6. So now I need to isolate. I'm going to do it again, kind of follow the steps again. Isolate my radical, eliminate the radical, solve, and eventually check for extraneous solutions. Okay, so this one, if I want to isolate that, I'm going to divide both sides by 2, giving me the square root of x equals 3. That's actually a really easy one to solve. You've been doing square root problems like this for a long time. In fact, we're going to square both sides, and I'm going to get x equals 9. All right, so I need to check to see if 9 is in fact a solution or not by putting it back into the original. All right, we'll use my other marker for this. And let's try it here. Square root of 9, I'll do it on the side. Square root of 9 plus 1, does that equal the square root of 9 plus 7? So the square root of 9 here is 3. 3 plus 1 equals the square root of 16. And I have 4 equals 4. So yes, it does. So since that side equals the other, this is not an extraneous solution. It actually works. And it would be a real solution of your problem. Now, if you plug it in and you get 4 equals a different number, like 4 equals 0 or 4 equals 2 or something that's not the same, then you would call that extraneous and you would reject that as an answer. All right, I didn't think that one was maybe as hard as I was hoping for. So if you want a harder one, you can check out this video right here. That really does get into a really tough radical equation.